get into it. Welcome back, everybody. So I have your exams up here graded. I'll pass them back during the break. That way, we don't want I just don't want you guys to get distracted and want to look at your exam during class time. But we'll continue where we left off. And then also during the break, I want to talk about this. BS. But people can't really read. We can't really do that over the lecture recording because you can't see what I'm talking about. Anywho, so we learned at the very, very end of last time, we had learned all the quick rules to calculate things very quickly. Specifically, the most important rules from the first section were the power rule and the constant multiple rule. Everyone else, like the derivative of constants and stuff, also useful. But then we also learned a few new rules that the derivative of e is itself, the derivative of natural log is 1 over x, and then the derivative of any other exponential or logarithmic functions are listed on there. Natural log of a times a to the x, or 1 over ln of b times 1 over x. That being said, you do not need to have those memorized. As I said before, I've been studying mathematics for God knows how long at this point, and I can count on 0 hands the number of times I've actually needed to find the derivative of log base b or a to the x for some weird base. If your teacher in Math 182 asks you to find a derivative with those things, they're being unnecessary. Tell me, email me, and I'll come and I'll joust them. Serious. I will slap them in the face. It's unnecessary. It's unnecessary. It's stupid. And the reason I will say that is that every exponential can be rewritten with the exponential base, with the natural base. Every logarithm can be rewritten as a natural base logarithm. So there's no point to learning those derivatives because everything can be converted to e to the x and natural log. So I disagree, and that's just from my class. And if it does end up happening, I promise you, you can email me and I will have a discussion, a heated discussion that might lead to jousting. So anyways, let's actually do some computations. And so, yes, I have it on this problem to do it. Yes, I have log base 7 on this problem. That's like the last time you're ever going to see it. I promise you on my exams, you will never see log base 7 derivatives or 21 to the x base derivatives. But since we're doing it here, y prime or dy dx, let's write dy dx. Let's give Gottfried Leibniz some love. Derivative of e to the x is itself. By the power rule, the derivative of 2x cubed would be 6x squared. Now, here's where I would want to do a little bit of side notes. 7 times the 5th root of x. By the way, that is 7 times the 5th root of x. I will try to make sure if this is a problem on an exam that it is very clear that 5 is not attached. This is not 75 times the square root of x. Please don't make that mistake. This is 7 times the 5th root of x, which is really 7 times x to the 1/5. So the derivative of that, the reason why we converted it to exponential form is that way we can use the power rule, the derivative of x to the n. So this will be minus 7/5 x to the negative 4/5. Make sure you understand where that came from. And if you don't, please feel free to ask, but take a second to make sure you get it. It's okay if you don't, though. And it's from the power rule. So 7 times 1/5, that's 7/5. 1/5 minus 1, that's negative 4/5. And then the derivative of log base 7 would be plus 1 over ln of 7 times 1 over x. And that is our derivative. G of x, the derivative of that. So that's going to be, g prime of x. Derivative of natural log is 1 over x. So this should be 3 times 1 over x or 3 over x. Derivative of a to the x for anything is natural log of a times a to the x, though you don't need to memorize that. So this will be minus natural log of 21 times 21 to the x. And then the derivative of 5 is a constant. So the derivative of a constant is 0. So we're going to just skip writing it because adding 0 doesn't do anything. Any questions on those? Okie dokie. Move on to some actual problems that I really like. Determine the values of x for which the function h of x is equal to 2x cubed minus 1/2 x squared minus 15x plus 3 has a horizontal tangent line. So we're encountering this problem first time, but we have to remember key fact number 2, that the derivative, like when you plug in a specific value into the derivative, you get the slope of the tangent line at that x value. So by saying that I want to have a horizontal tangent line, that means I want h prime of x equal to 0. Because the horizontal tangent line means you have a slope of 0. And so since the slope comes from the derivative, we're saying that we want h prime equal to 0. So we got to find the derivative, which now that we know the product rule and stuff, could you imagine trying to do this by the definition? Good news is, guys, now that we've done it once, we don't need to do it again. We're not like, I don't think we're ever going to see it again, the definition. We can move on. It's just a process that you have to do in mathematics. You have to be hazed a little bit. That's one of the things that are very common, even at the graduate level. When I was taking differential geometry, my teacher had to, I had to prove that the sphere was a surface. And it took me 5 pages to do. And then the next day, he's like, okay, so now we know how to prove that things are surfaces, so we'll just assume that they're surfaces and call it good. So good 5 pages and 12 hours wasted doing that. But it's how you grow. It's how you grow. So that's what I have to tell myself. Otherwise, I wasted that time. H prime of x. Just a bunch of power rules. H prime of x would be 6x squared minus x minus 15. That's all by the power rule. I technically plus 0, but we don't need to write plus 0. And so setting it equal to 0, I'm going to actually make that equal to 0 in red. And then we got to factor it. And once again, if you don't want to factor it by hand, you can always use the quadratic formula, but you should definitely try. And so I'm going to try and do this by hand. I'm going to guess that it's going to be 2x and 3x to start off with. And then if I did 3 and 5, 3 and 5 would work. 3 here and 5 here. Minus and then plus. Right? Because then I get 6x squared plus 9x minus 10x would give me the minus x and then minus 15. Excellent. Good to go. But you can always use the quadratic formula. And in fact, if you have the calculator that I suggested, this thing can actually solve quadratics for you. If you want to know how to do it, please let me know and I'll show you on the calculator. It has to do with the menu. The menu allows you to do a lot more calculations. You can do solving if you go down a little bit. So either way, we'll get to that later. So this gives us that x is equal to -3/2 and 5/3. Those are the x values, and I'm done there because all it wanted me to do was find the x values. It didn't ask me to find the points on the curve. It didn't ask me to find the tangent lines where you have a horizontal tangent line. It just asked me to find the x values. Any questions on that?
So that means at those points, just for a super small segment, it's got a horizontal tangent line before it shifts or something?
Mm-hmm. And in fact, so if you guys remember from Math 126, what a cubic function will look like, they either look like this, which this one doesn't look like it. That's one where you have 2 complex zeros and 1 real zero. But most of the time, cubics look like this. Where are the 2 places that you have a horizontal tangent line? Where it changes from increasing to decreasing or decreasing to increasing. At a relative max or a relative min. Interesting. Interesting. We have a horizontal tangent line where we have a relative max or a min. I wonder if that's a rule. But we'll get to that. That's in unit 3. Next one. Find the equation of a tangent line to the curve f of x equals 3x squared and is perpendicular to the line 3x plus 18y is equal to -7. Whew, there's a lot to think about there. we want our line to be perpendicular to that line, given. So what do we like? This is the thing that I do when I'm as a mathematician, when I'm finding a problem that I do not know how to solve. Say, well, what do I need to find? I need to find the equation of a tangent line. Two things that I need for a tangent line, either 2 points or the slope in the point. So for the slope of the tangent line, how would I find it? Slope intercept form could like be one way to find it, to write that equation of that line that's given.
Oh, well, from this one, we'll just get the slope of the curve, of what we're gonna look for.
Yes, so Louis is exactly right. We're going to look at the slope of the given line, and then that will allow us to find the slope of our tangent line. So first, find the slope of the line that is perpendicular. If everyone okay, is everyone okay with this symbol to mean perpendicular? The upside down T? Upside down T means perpendicular. Later on in your math for you to change it from perpendicular, you'll start saying orthogonal because it sounds way cooler. It's the only reason why they say orthogonal. It just sounds way better. But find the thing that is perpendicular. So 3x plus 18y equals -7. You're going to solve this. You're going to solve for y to get it in slope intercept form. So 18y is equal to -3x minus 7. And then we'll divide both sides by 18 to get y is equal to -1/6 x minus 7/18. And oh no, the y-intercept's all nasty. It's all 7/18. That's not a nice number. Doesn't matter. We don't care about that. We're only interested in our line's slope. So we don't need to care. We don't care about this line's y-intercept. It's not useful to us. So the m of the line is equal to -1/6, which implies that m subtangent is equal to +6, because the perpendicular slope is the negative reciprocal, i.e. you flip the fraction, change the sign. So m tan is, I'll write it down, so that's -1 over -1/6, which is +6. In case you've forgotten about that trick about how to find perpendicular lines, it's the negative reciprocal. Flip the fraction, change the sign. So we got the slope. Excellent. Now for the point on f of x. It didn't tell me an x value. It didn't tell me an x value, so I can't find a y value. What do I do?
Test points.
Test points, not a bad idea, but unfortunately there's infinitely many, and keep testing it to figure out where it would be very, very challenging. We know that the slope of the tangent line is 6. And because the slope of the tangent line is equal to 6, because m sub tan is equal to 6, that means that h prime of x is equal to 6. H prime of x is 6x. Right? H prime of x is 6x. So this allows us to solve for x. So this curve in particular, 3x squared, and you can verify this by looking at it, there is only one spot on that curve that has a tangent line with a slope of 6. Because if you think about the curve of 3x squared looks like this. And so if you draw any tangent line, every single one is going to have a unique slope. There's never going to be a repeat, because you're going to get more negative over here, and then less negative, less negative, less negative, 0, more negative, more positive, more positive, more positive, more positive, and it just keeps increasing. So there's only one x value on your curve that will have a slope of 6. Does that make sense? I can say that again, maybe in a different way if you need me to. The point being is that With this curve, there is only one spot. Now, with other curves, for example, if I were to draw this curve, there are probably two spots where the slope of the tangent line is 6. There's probably one right here, and there's probably one right here. But either way, this curve only has one, but like you still solve it the exact same way. You're going to find the x value by utilizing the derivative. So 6x is equal to 6. That gives us x is equal to 1. And that's only the x value. Now we need to find the y value, which is the function value. Because remember, this is a tangent line to f, not to f prime, but to f. So f of 1 would be 3 times 1 squared, which is 3. So that gives us the point 1 comma 3.
Remind me what H prime was again?
H prime is the derivative of h, or
It's F, right?
f. I don't know why. I don't know why I liked h. F prime. Sorry. Thank you for catching that. Testing your guys' literary skills. Making sure you know the difference between F and H. Okay. So we have a point, we have the slope, we know everything we need to know. So this is a situation where the slope, we found it without actually having to plug in any numbers into the derivative. Because it was just given to us because we knew that our tangent line was perpendicular to the given line. We didn't need to do any calculations with it, but we did need to use the derivative to solve for the point on the curve. So then we write it in the way better form. We write y minus 3 is equal to m, which is 6, times x minus x sub 1, so x minus 1. Or if you want to be lame, y is equal to 6x minus 6 plus 3, so minus 3. And let's just make sure that's in very, very small writing. Because it's way less important. Have beef against them. Sorry. It's not like. Once again, though, what our rule of things to do. If you're going to, and this is going to be especially important moving on in this segment and beyond. If you need to utilize your answer for something, if you need to use your derivatives for something, or if you need to or use a line for something, use an expression for something, simplify it. If you don't need to use it for anything, if you're just being asked to find the tangent line or just being asked to find the derivative, don't bother simplification. Don't bother with the simplifying. It's not necessary. Yes.
I'm probably wrong on a lot of this, but the derivative is the equation of the tangent line, right? So
this is a hard situation. We actually we didn't hire someone because they made this mistake. One of my colleagues way back where the tangent line, like the derivative, can represent the tangent line slope. The slope, it can represent the slope of the tangent line when you plug in a specific value. As a pure entity, as f prime of x, that is a function. But when you plug in specific values into that function, then you get the slope of the tangent lines. Does that make sense?
yeah, my only concern was like, so when we got this slope and then when we set it equal to f prime, like, I think my question is something like, we got 6x, but technically if we just knew the slope, couldn't it, like, would 6x plus 3 or whatever, 6x with something behind it have not been equal? Like, why is it just 6x?
Because that's the derivative of f of x. So the derivative of 3x squared is 3 times 2x to the first
Oh,
power.
the power rule.
Yes.
That's what I missed. Okay.
Excellent. All right. This problem, I love this problem. It's probably my favorite problem on this one. It's going to take a while. It's going to take a while, and that's why it's awesome. Okay. So this one really stretches your knowledge of the material. Find all the tangent lines to the curve f of x equals 3x squared plus 12x minus 7 that pass through the point 3, 8. A graph of f and the point is provided. So this is f of x. F of x is equal to 3x squared plus 12x minus 7. and this is the point 3, 8. I know it's not to scale, but that's kind of by design. So I do this picture to show us that there should be 2 tangent lines. There's going to be one right about here. Let's move that up. Come on. Bill, is this really a good use of your time? Yes, it is. So we should get 2 tangent lines. We should get that one, and we should get one probably right about here. Right? Point being is that there will be 2. Now, I'm going to get rid of the pink one for a second to talk about, it doesn't matter which one. We're going to think about it arbitrarily. This is a point. Let's highlight in red. This is a point A, B on the graph. Okay. I need to find the equations of the tangent lines. So with a tangent line, I need a slope and I need a point, or I need 2 points. Now that's important to remember. You can find slope in one of 2 ways. You can find the equation of a line in 2 ways. You can either have 2 points on the curve, or you can have a point and a slope. So first need the slope. I mean, you can start with whichever one, but I'll tell you, if you try and start by finding the point, it's going to cause a lot of issues. So it's better to find the slope. And there's 2 ways we can get it. Now, before I continue onward, why do I say that you can get it in 2 ways? Because the first way to do it, like the natural path, especially since we've been doing calculus, would be like, oh, yeah, I'll just find the derivative. I don't know why I keep going with H. Don't write this down, so I'm going to write this in red. F prime of x would be, okay, 6x plus 12 minus 0. That's it. How do I find the slope, though? I don't know the point on the curve. I know the point that's not on the curve, but that's not useful for finding a tangent line. That, like, if I were to try and plug in 3 into my derivative, I'd be finding this tangent line right here. And that doesn't cross through the point 3, that point doesn't cross through 3, 8. So plugging in 3 isn't going to get me that tangent line. So that's why this becomes an issue. So the derivative doesn't actually give me the slope yet. So option one is to use the derivative, using derivative. And that would be f prime of x is equal to 6x plus 12. But as I said, the problem here is that we don't know the point on the curve. It's an arbitrary point at this juncture. So I don't know what to plug in. So I have to just leave it there. Now there must be some other way, right? I have 2 points. Option 2, slope formula. Yeah. Sorry. Let me I should have put this here as well. I should have put this. So I'm writing this as an arbitrary point A, B on the graph. We don't know what A is, but it's just some arbitrary point. So f prime of A would be 6a plus 12. That's equal to m tan. We don't know what A is, but we're just going to plug it in for now. And the slope formula, if you guys remember, is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We have 2 points. We have 3, 8 and A, B. We have 3, 8 and A comma B. That's a problem though. What's B? Because so what we're gonna do here in a second, so don't write this down. This is what mathematics is all about, in my opinion. I haven't said about it in this class. One of my favorite things when I was in grad school was studying a class in mathematics education, and it was and one of the articles that we were watching as a teacher took her students that were very proficient in the mathematics for their age, and the students that were performing at level, and she gave them a very difficult math problem for their age group. And she studied how they went about it. And the students that were that were above average in their mathematical skills, what they would do is they'd go down one path until they got stopped. Then they go back to the beginning and try a different path. If they got stumped, then they go back to the beginning, maybe try the other one and get a little bit farther, and then get stumped, come back and keep going until they finally got the answer. Whereas the students that were less proficient at that level, they would go to the same point, they'd go back to the beginning, try again, the same spot, go back to the beginning, try the same spot, and keep getting stumped. So the point being is that it's okay to mess up. Go back to the beginning, try again. Maybe you try it a different way, maybe it works out. If it doesn't, go back to the beginning, try a new way. Maybe you get closer. So the point being, so don't write this down, this is just for observation purposes. These are two ways to find the slope. So m is equal to b minus 8 over a minus 3. They need to correspond. When I plug in a into f prime, I get the slope of that orange line. But if I use the slope formula, I also get the slope. So those should be equal. They need to be equal. So what I'm saying is that this should be equal to f prime of a. And I've got an equation that I can solve. However, the problem being that that's a two-variable equation because it's got a's and b's. So there must be something I'm missing. And the key thing is that we can find out what b is. What is b? I'll give you a hint in case you don't already know. This is a point on F. A comma B is a point on F. So note, since A comma B is on F of X, that means that B is equal to F of A. It's the function value at A. Right? Whenever you're trying to find the y value of a point on your curve is always the function evaluated at that point. So that's going to be 3a squared plus 12a minus 7. So a comma b is a comma 3a squared plus 12a minus 7. Now there's a lot going on here, yes, Dave.
Oh, why is it y instead of x? That's the because we have the given points and then the points we're trying to find, and because it's like on the curve, that's why we know y. Why is it not x instead of y?
Why are we using x instead of a? Why are we using a instead of x? Is that?
Or no, why do we know y is 3 instead of a?
So this is not a point on our curve, so it's a separate point. This is an arbitrary point that we know must satisfy that equation. So since we don't know what it is, we're just going to label it as a comma b. Does that answer it? Probably not.
No, but I got confused in what I was trying to ask it.
For sure. If you think of it, please let me know. So let's recap now that we've talked about going through the process and going back to the drawing board and back. So I don't know what the slope of that line is. I'm going to call it a point a comma b because I know that that's what the line should look like. And then the other thing is that I know that since this is a point on the curve, point b, the value of b should be f evaluated at a, which is 3a squared plus 12a minus 7. Now, since I do not know what that a comma b point is, I have no idea what to plug into my function. If I knew what that point was, it looks like it might be like -1, but then again, the scaling here is kind of ridiculous. So there's no real way to truly gather the information. So I try to find the derivative and I plug in that point, I get 6a plus 12. That has to be m tan, but there's no way to know what a is. So there must be something else. And I look at another way to find the slope by the slope formula. So m sub tan could also equal 3a squared plus 12a minus 7 minus 8 divided by a minus 3, or preferably 3a squared plus 12a minus 15 divided by a minus 3. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So since I made the secondary point, I made a comma b my x sub 2 y sub 2. So these need to be equal. Those need to be equal. If they wouldn't, we would have broken mathematics because the slope formula is a guarantee. We know that the slope formula works, and we know from calculus that the slope of the tangent line can be found by plugging in a specific value into the derivative. So they should be synonymous. They should be equal. Yes, Louis.
And it wouldn't make a difference if you flip flop the points.
Nope, it would not. It's just going to make you have to deal with a lot of negatives, which I don't want to deal with.
So generally, if we're trying to do this format with variables in one of the points, we should try to put that first.
Probably.
Okay.
It's not going to be terrible because, like, at the end of you'll see what happens in a second. It's just you run more risks of making a small error if it has multiple terms, because then you'd have to distribute the minus sign.
Okay.
If these two things were flopped, then you'd have to distribute the minus sign into those three things. And if you forget to do that, then you're in bad luck. You're in a bad shape. So these must be equal, meaning that we have 3a squared plus 12a minus 15 over a minus 3 is equal to 6a plus 12. That's the first part. The left-hand side of the equation is the slope from the slope formula. The right-hand side of the equation is from the derivative. So that's an equation. It's a rational equation, and we can solve that. Nothing too terrible. Now, you can do it in a multitude of ways, but the way I would do it is I would multiply both sides by a minus 3. They cancel that on the left, and I know you're probably thinking, Phil, you can't multiply by a variable. We learned that way back when. You can't multiply by variables. I can do whatever I want. No, in particular, the reason why you don't want to multiply by variables is that you don't want to be, and like a variable could be 0. But if a was equal to 3, that would cause it to be 0. But that's not going to be a problem. H can't be 0. We just remembered that wouldn't be, if we plug in 3, that point doesn't go through. So the value of a cannot be 3. So it's okay to do this in this context because a minus 3 is not going to be 0. That's why I can do that. Anyways, we get 3a squared plus 12a minus 15 is equal to 6a squared minus 18a plus 12a minus 36. And then we've just got we got a polynomial equation. We can solve a polynomial equation. So I'm going to bring everything to the right-hand side because I want my leading coefficient to be positive, but it's okay, however you want to do it. You get 0 is equal to 3a squared. So this right here is negative 6a. You're going to subtract 12a, so that's minus 18a. And then you're going to add 15 to negative 36. That'll give you negative 21. Right? Yeah, minus 21. And aha, that's a polynomial equation. And maybe the numbers are nice. Maybe they're not. It looks like there's a nice factor of 3. So that's 3 times a squared minus 6a minus 7. And that factors to 3 times a minus 7 times a plus 1, which gives us a is equal to 7 and negative 1. That's not our answer, though. We got more to do. But once again, I want to recap this. This is such a good problem in making sure you understand the connection between the derivative and the slope of the tangent line, and also the concept of starting over again. I had originally started by trying to do b minus 8 over a minus 3, but then I realized that I can't solve a two-variable equation, so I have to go back to the drawing board. Maybe I try something different. It still gets me stumped, so I go back to this, and then remember that b is a point on the curve, so b is equal to a squared minus plus 12a minus 7. Right? All these things can happen. So those are the a values. That means that we need to now find the slopes and the points on the curve. So now we've found the x values where tangent lines will go through 3, 8. Let's get the equations now. Now that we know the x values, we can plug in the x values into the derivative to find the slopes. Because if you remember it, like that's the reason why I draw the two different lines. One slope is pretty tame and the other one's pretty steep. So there should be two different slopes. They shouldn't be the same value. So let's work with a equals 1 first, or a equals 7. So for the slope, f prime of 7 would be 6 times 7 plus 12, which is 6 times 7 is 56. Plus 12 would be 68, right? 42. I know my times tables, I promise. I was thinking of 8 times 7. What am I doing? 54. So that's our MTAN. And then our point, I'd plug it into the original function because this is a point on F. It's not a point on F prime. I know I keep saying that. You might be thinking I'm sounding like a broken record. It's because it's a common mistake. I don't want you to make it. It's a point on the curve, not on the derivative. So point f of 7 is 3 times 7 squared plus 12 times 7 minus 7, which ends up being, so 3 times 49 plus 12 times 7 minus 7 gives you the point 224. So 7, 224, which gives us y minus 224 is equal to 54 times x minus 7. And if you really want to convert that to slope-intercept form, do so. I don't recommend it. It's just enough. We've done enough already. Do we really need to do one more thing? That's one of the lines. And yeah, that looks like a massive slope, but remember that this curve is not to scale. If we go back up, don't worry, I'm coming right back to it. That would be when a is 7, that's like over here, and that's going to be a very steep line. So 54 seems a little reasonable. Next, we'll do a equals 1. Or a equals -1, that's right. So f prime of -1 would be 6 times -1 plus 12. That's 6. That's the slope. And the point f of 1 would be 3 times 1 squared plus 12 times 1 minus 7. 15 minus 7 is 8. So we have the point -1. Oopsies. What am I doing? You guys should have caught that. F of -1 to find the point. 6 times, or no, 3 times -1 squared plus 12 times -1 minus 7. That's 3 minus 12, that's -9 minus 7, that's -16. So we have the point -1 comma -16. And so we have y plus 16 equals 6 times x plus 1. All right. Boom. Isn't that fun? Isn't that an awesome problem? All that knowledge busting out in one of them. We had to bust out the slope formula. I bet you didn't think you were going to use that again. Right? I don't need to do that. That was 126. 126 was boring. I don't like that. No, you're going to need to use it. Every once in a while, they come back. Long division, by the way, really going to come back in 120. Not really. Sometimes comes back. Long division does come back every once in a while. Polynomial long division. Sadly, you can't always do synthetic. You know, synthetic's better. But either way. Okay. Any questions on that? Let's do you guys want to recap it one more time? All right. So one more time to recap. The thing is, we don't know what the equation of that line is. That's what we're trying to find. And I've drawn the picture to kind of visualize it for myself. Now it has to go through the point 3, 8. So 3, 8 is not on the curve. It could be, but like the picture has shown that it's not. So I draw a generic line on there and say, okay, well, it has to touch the graph at one point. That's the tangent line. So that's a point A, B. We don't know what it is. We're trying to find it. Now, the slope of the tangent line comes from the derivative. That's the first way we would try and do this because this is calculus. So I find f prime, 6x plus 12, and I plug in that point, but I don't know what that point is. I'll call it A. So I get 6a plus 12. So I don't know what it is. So there must be some way to solve for it. There must be some way to find it. And then I notice that I have 2 points then. I have a point A, B and a point 3, 8. So I can use the slope formula. And if I can set those two things equal to each other, I can solve for the A value. Because those things can give me an equation and we can solve equations. We've practiced solving equations a lot over our mathematical career. So the problem was, though, that A, B has 2 different variables. So trying to solve it in its generic form, A, B, would be an impossible task. But because A, B is a point on the curve F, that means that the B value, your y coordinate, is the function evaluated at A, because it's a point on the curve. So B is equal to f of A, which is 3a squared plus 12a minus 7. So your point A, B is A, 3a squared plus 12a minus 7. So the slope formula using these 2 points becomes this, 3a squared plus 12a minus 15 over a minus 3. Because the slope formula and the tangent line slope should be synonymous, we're going to set them equal to each other and solve that equation however you want to. What I did is I multiplied both sides by a minus 3 to get rid of the pesky fraction. And then I have a polynomial equation, which I can solve by bringing everything to one side so that one side is 0. And then I will take care of it from there. I factor it. And if you don't want to factor it, you can always use the quadratic formula. It'll work out. We're not looking for factors in this point. We're just looking for the values. So there's not really any need to factor it. And now that we found the A values, those are the X values on the curve. They're the points on A, on this thing. So it looks like this is -1. And then over here, so double that and then add 1 a little bit. There's 7. And if I were to draw this point up here, I'd get a line that goes through it as well. So I found the X values, but that's not enough. We want to find the tangent lines. So we need to do one last step. One last step. Just one little thing, just one little baby extra thing of finding the slope and the point. So the slope comes from plugging it into the derivative. Though if you really wanted to, and this would be a great problem for this weekend, maybe with your significant other, plug it in, plug in -1 into this and see that you get 6 as well, or 6 as well. You will. So either way, you can plug in the A value into either version of it. You should get the same number. You'll get the slope of the tangent line, then plug in the point to find the actual, or plug in the X value to find the corresponding point. And then you've got your equations. However nasty they may be. Yes,
So we plug into the derivative, because that's that example that you mentioned, that with the point given, now the derivative is representative of the equation of the tangent line.
the slope of the equation, the slope of the tangent line, yes. So now that we found the x value, we can plug in that x value into the derivative to find the slope.
Oh.
of the tangent.
And then the derivative equation, again, I don't know why that's the one that's tripping me up, but it's just taking the original and doing the power rule. That's
Exactly right.
6x.
Exactly right. Now, by the way, if you're freaking out about this, that's understandable. This is a hard problem. This is probably like, this would be a 12 or 15 point problem and and you'd have a whole page to do it and and I'd make sure that you had plenty of time to think about this problem on an exam. Will I actually do it? I don't know. Depends on if the Seahawks win or lose during that week. So just pray, better be praying for a Seahawks win, okay? But any other questions? Jaden, I think you had your hand up.
I was gonna ask for a recap for the recap. but-
The recap. This is a hard problem. It takes a long time to digest. Yes. That's from the power rule. So the derivative of this f prime of x would be 3 times 2x the first power plus 12 times 1 minus 0, which is 6x plus 12. That's where I'm getting it. I'm taking the derivative of f using the power rule.
Oh,
Any,
I
oh, go ahead.
forgot about that. That's because any constant, if we're doing the power rule, equals 0,
Mhm.
because it's 5.
Yes, the derivative of any constant is 0. This problem takes a lot to digest. This is grape nuts right here. This is like if you've ever had grape nuts, they're a very, very hard thing to eat. Does everyone know what I'm talking about? Please tell me I'm not like going crazy by talking. Who knows about who doesn't know about grape nuts? Okay, go to your cereal aisle. It's a bunch of really tiny, impossible to eat, crunchy things that take way too long. It's great fiber, but it's terrible. So way too expensive too. But this is hard to digest. It takes a long time to chew it up and break it down in your mouth. So anyways, moving on. Applications. Last thing. So as you remember, the velocity is the derivative of position. So velocity can be negative, by the way. I know position, you can't go you can go backwards if you're talking about from your starting point, but if I'm walking forwards, my velocity is positive, whereas if I'm walking backwards, my velocity is negative. So it is okay for your velocity to be negative. Your speed is different from velocity. Speed is always positive because it's measuring how fast you're going, regardless of your direction. Whereas velocity is based on a reference of whether you're going away from your starting point or going back to your starting point. Anyways, so the position function of an object, I don't know what it is. I don't know how we measured it, but S of t is equal to 1/4 t to the 4th plus t cubed minus 8t squared minus 48t, where S is measured in feet because this is America, and t is measured in seconds because everyone works with seconds. Though I would imagine America, if we had done it differently, we probably would measure things differently because we are weird. We like our freedom units. But anyway, so find the velocity of the object after 5 seconds. We are trying to find v of 5, i.e. find v of 5. Since v of t is equal to s prime of t, v of t will be the derivative of that, the derivative of s. So 1/4 times 4, so it should be t cubed plus 3t squared minus 16t minus 48. That's v of t by the power rule.
Which one was the quarter t to the 4th?
That's the derivative of that will be t cubed. Because it'd be 4 times 1/4, so that fraction goes away, and then t to the 4 minus 1 is t cubed. And so we're just trying to find V of 5. I don't want to plug it in my calculator. V of 5 will equal 72 feet per second. And I want to talk about that in a second. Y is the measurement. So S is measured in feet. Why would velocity be measured in feet per second? And that's has to do with the definition of the derivative. So we'll get to that in just a moment. Then the next question is determine the times, the t values, when the object is at rest. Now, this is something, if this problem was on an exam, I'd be very, very particular. An object at rest means that it has 0 velocity. It is not moving. Object is at rest. That means, i.e., v of t is equal to 0. No velocity. If you're at rest, you have 0 velocity. You are stuck in one position. So setting v of t equal to 0 implies we have t cubed plus 3t squared minus 16t minus 48 equaling 0. And that is quadnomial. And who knows how to factor a quadnomial? I mean, yeah, we could bust out the rational zeros theorem. Do you guys want to do that? You guys want to bust that out? Did you think that you have to use that again? You're not going to have to use that. This is actually, so Blaze, factor by grouping, yes. Which is something that you might have forgotten about, but you factor it right down the middle. You factor out mini GCFs. From the first two terms, there's a common factor of t squared. So t plus 3. And then from the second set, I'm going to factor out a mini GCF, which would be 16, because 48 is divisible by 16. So minus 16, and I get also a t plus 3. And so I do have a common factor of t plus 3 between the first term and the second term. So that can be factored out front. T plus 3 times t squared minus 16, which gives us t plus 3 times t plus 4 times t minus 4 is equal to 0. If you didn't know how to do factoring by grouping, it's okay. It's something we have, like, you don't do very often. And I actually had one student do this on an exam, or one of your guys' exams, and I loved it. They explained they didn't know how to do the problem, but they explained how to do it. I love that. That is the best thing. So if this was you on the exam, you know that you need to set this equal to 0. Write on your exam, I don't know what the value, I don't know how to factor this, but those will be the times that end up being it. That tells me that you know how to do the problem, but you just didn't know how to factor. I give you extra credit. Like, not extra credit, but I give you more credit than if you just left it blank or tried doing some gibberish. Anyways, you get t equals -3, t equals -4, and +4. But those two don't make sense. It's in Avengers Endgame. There's no going back. No reversing the snap. You can't do that. I used to say this ain't Back to the Future, but that reference is becoming dated at this point, which is a damn shame. It's a great movie. Great series. But either way, so this, you can't have negative time. We just can't have negative time. Not yet, at least. Maybe one day. Maybe in your lifetime we'll figure out time travel, but who knows?
I think it's just gonna be, hey, I've seen this one before. What are you talking about? It's brand new.
Yes. That's a joke from Back to the Future, by the way, in case you missed it. It's a good joke. Thank you for that. So t is equal to 4 is the only one. 4 seconds. So just as an aside, because you might be wondering, like, I'm glad you're curious, Blaze, about why it's feet per second. I'm glad you asked about that question. So why is the velocity measured in feet per second? By definition of the derivative, v of t is going to equal the limit as h approaches 0 of s of t plus h minus s of t divided by, well, actually, it should be better. It'll be betterly visualized as t approaches a of s of t minus s of a all over t minus a. Better visualized this way. Once again, this is why we want to study both of them. S of t is measured in feet. S of t minus S of A would be some foot measurement. The American foot measurement, and T is measured in time, in seconds. So we have feet per second. That's where it comes from. Acceleration, which we'll talk about sooner than later, actually in the next section, is feet per second squared, and so on and so forth. So that's where everything is coming from. That's the reason why it's feet per second. Do you need to know that for this class? Probably not. But if you're trying on taking physics, you might, but not for my class, because this isn't a physics class. I don't really like asking too many application problems. That's better for the physicists to do. And this problem is stupid. Forget it. I just made that graph when I first started working here, and I wanted to use it in a problem, but it's not good, so don't do it. Anywho. We'll move on to 2.3, but we're at a good stopping point for a break. We're going to come back at 12:05. So people watching the recording, go ahead and do some guided meditation or something. Okay, I passed back your exams. A couple things. So now that we've been handed back, you have until next Wednesday to return it in for up to 50% of credit back on the points that you lost. So if you got an 80, that means you lost 20 points, or you missed out on 20 points. You could get 10 of those points back, leading you up to a 90. If you got a 50, you list out on 50 points, you can get up to a 75. So you can go from an F to a C plus a standard C. So that brings up 2 points that I always want to mention with my students. No one exam score defines who you are as a person. If you didn't do as well as you hoped, that's okay. It happens to all of us. I actually failed one of my exams, like 2 of them at least. I actually failed one of my courses in undergrad. Not failed, but failed by my standards and by grad school standards. So took a long time to get over that loss. But point being is I am not that mistake. That was just an easy mistake. It was his fault, not mine. It was my teacher's fault. I'm kidding. It was mine. But either way, don't take it personally if you didn't do well. It's okay. It all happens to all of us. But the good news is in my class, you can recover from those things. You can really raise it. And that is the reason why I have the redo policy. So as a reminder about the redo policy, do you have a question?
Oh, no.
Okay. As a reminder of the redo policy, the only person you can talk to for help on this thing is me. You can look at any video or any lecture notes that you find online, any examples that you can find, but nothing that tells you how to do the problem. Is that clear? Nothing that says like you show it the problem and it says this is how you do it. Nothing like that. If I find out, it is considered academic misconduct and I have to pursue it. And there's a lot of things that I can tell in those situations. So please not take advantage of the system. Because if people start taking advantage of it, I have to get rid of it. I really want this procedure to work. I want this to be a learning experience for all of us. And so I'm happy to answer any emails you have about it. I love answering these emails about this exam. So the other thing I will tell you, speaking of which, every single problem on the exam, I guarantee you there's at least one problem in your notes that can help you figure it out. So your notes should be sufficient, but you can always look at different videos online as well and other textbooks and things like that. But you can always ask me for help, even if you don't even know what to do. You can say like, I don't know how to get started on question 6. Ideally, you've tried something, but if you haven't, you can always ask and I will tell you where to start looking. I will be looking at my emails frequently throughout this week. You can stop by during my office hours, which are virtual now, by the way, so you can always just log in from the comfort of your own home or whatever. You can access that link on our Canvas homepage. They're from 12 to 10 to 12:20 on Tuesdays and Thursdays. So you'll be able to get two office hours tomorrow and then Tuesday before the exam, before it's due back in on Wednesday. You do not need to redo the entire exam. If you got a question right, no need to redo it. And you don't even have to do all of the parts of one of the problems. So it is okay to skip problems if you don't know how to do them. You don't have to do the whole thing in order to turn it in for some partial credit back. Second thing, you'll notice that there are not many there's not much verbiage on it. There's just usually check marks or something like that. Occasionally, some students were trying to plug in test values to determine a limit. That is a way to check your answer that is not sufficient to prove an answer. So you need to use calculus. You need to use the techniques that we've learned in 1.2, 3, and 4 to figure out those limits. If you're confused on any of those things, why something was marked down, you can always ask. Not a problem. I will never make you feel. I will never make you feel bad for asking questions. The other thing is, please make sure. So the way I grade my exams is I grade each page, and then I put the score in the bottom right or bottom left-hand corner for that page. So if you got 10 on the first, like question 1, 10 on question 2, I'll write a 20 at the very bottom of that page. And then I will transfer that to the front. Now, I am human. I can make mistakes. So if you see any mistakes in the arithmetic, please let me know. It's happened before. I remember in my grad school, a student got a 15, but the 1 didn't register on my calculator. So they only got a 5 on that problem, which dropped them down 10%. I don't want that to happen to you. If that happens, easy fix. At the end of the day, though, please advocate for yourself. If you think you deserve more points, come up and ask. What's the worst thing that can happen? I say no. Best case scenario, I say, oh yeah, I'm sorry, the Seahawks fumbled at that point and I marked you down because I was angry. Hopefully that hasn't happened. I'm usually pretty fair grader, but I am not infallible. Wait, is infallible mean what? I am not without, I have flaws. I make mistakes. So please let me know. And you can either come to my office hours or email me directly with questions that you have on the exam. Say what? Yes. But you can like we can talk about each problem. You can even as long as you have a webcam, or you can just, or if you have your phone, you can even just flip the camera and then share your screen essentially, or just with your face, but just show it on your exam so I can see what you did. Or we can talk through it out loud. If you want to know the max amount of points you can get back, take your score X plus 100 minus X divided by 2 is equal to potential new score. Yeah, X is your score. So if you got a 50 plus 100 minus 50 divided by 2, that's 50 plus 25, which is 75, and so on and so forth. So that is the formula. If you want to keep it, you don't have to. Anything else that I want to mention? Oh, so imagine this is my exam. Imagine this is my exams. The solutions, so don't look at them. But let's say this question. Oh, this exam is not. I don't have any. Darn it. Let's just use. People watching the recording, just talk to me afterwards. So this is page 2 of your exam. This is the first page of work. This is the cover page. The cover page. So this is page 1 of these, the important work page. Write your work on the back of the previous page. That way, when I'm grading it, I have both pages for reference. I have your original work and your corrected work. Is that okay? Please don't do it on the back of the page that it's on. Yes. Yeah, the one with the graphs, you don't need to redraw the graph. You can do it for reference. So don't redraw the graph. God no. There might be in the future a problem we have to graph, in which case I'll provide a graphing. That might be a smart thing to do, is on the back of that page, I'll put a graph of it so you can Yeah, I'll do that. If there is a graphing problem, not confirming or denying the existence of one on the next exam. But if there is one. Yeah. Any other questions? And, okay, the other thing is, so question 4, right? Question 4, was that the one that had the option? So, everyone say thank you to Bailey. Everyone say thank you, Bailey.
Thank you, Bailey.
Because she was the one who asked you guys if we could get it, if you did both of them, could you get extra credit? And I've decided if you do the one that you didn't do and you get it correct, I'll give you up to 2 points of extra credit after half credit has been given. So if you get a 50, you get a 75, you get everything perfect, you get a 75, and then you could get a 77. Okay. So if you want to, you can do the other problem that you didn't do for up to 2 points back, for 2 points of extra credit. Yes. What? Well, if you already did both, then kudos to you. No, I'm kidding. If you already did both, then just leave it as is and like maybe write on the back page said I did it here and then good. Yes. Say what? Yeah, an additional 2 points. So it's originally worth 10 points, but since you're doing it on top of what you're supposed to be doing, I'm giving you 2 points of potential for 2 points of extra credit. Okay. So 2 points of possible of extra credit, meaning a little nifty boost if you want. And that's not based on the 50%. That's added afterwards. Okay. So everyone thank Bailey for asking that question. She advocated for all of you guys. So anyways, continue on. Unless there's any last minute questions about the exams and the exam redo. Okay. So the fact of the matter is not every function is a polynomial or something that's just e to the x. What about e to the x? Don't write this down. What about e to the x times x squared? How do I find that derivative? Because we remembered that the derivative of f times g is not f prime g prime. Not how it works. And that gives us the product rule. So the product rule says that ddx of f of x times g of x is f prime of x times g of x plus g prime of x times f of x. The shorthand notation, which is the way you should memorize it, because I don't want to rewrite of x 50 million times. It's way too like that. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 different times. It's unnecessary. It's way too many pen strokes. The shorthand notation, fg prime is f prime g plus g prime f. Some textbooks might write it as g prime f plus fg prime, but some textbooks are wrong. It is not wrong to write it that way because multiplication and addition are commutative, but this allows you to memorize the quote. Like if you write it my way, it'll help you memorize the quotient rule easier. F prime g plus g prime f. F prime g plus g prime f. The quotient rule. The derivative, so ddx of f of x divided by g of x is equal to f prime of x times g of x minus g prime of x times f of x all over g of x quantity squared. Let's write that bracket better. F prime of x times g of x minus g prime of x, f of x all over g of x quantity squared. So the shorthand would be f divided by g prime is f prime g minus g prime f all over g squared. There are many different mnemonic devices, but I just kind of memorized it by brute force. I want this to be like that scene in Kill Bill Volume 2. If you guys remember when she's training and she has to punch the wall, right? She has to do it from a finger's length away. So, like she has to keep punching the wall and then she starts dreaming about it in her sleep and then ends up punching a wall in her sleep. I want you to wake up in a cold sweat in the next couple of weeks and immediately just draw on the wall f prime g plus g prime f and f prime g minus g prime f over g squared. Please, you're going to have to do this a lot. I recommend each time you start off when you're learning this, just rewrite the formula every time. It's free practice and memorization. Yes, Louis.
The product rule, so that means, just make sure I'm understanding correctly, that means the derivative of f times the function of g plus the derivative of g times the function of f.
That's right. So f prime times g plus g prime times f. F prime times g plus minus g prime times f. Yes. That's just the shorthand notation. That's how I memorized it. So every single time, if you're learning this for the first time, if you've already seen it before, awesome, kudos to you. But if you're learning for the first time, rewrite it every time you're doing a new problem that involves the product of the chain of the quotient rule, and you'll memorize it 2 times as fast. That is a lot. I don't know how fast it will be that you learn it. It's not necessarily 2 times, but it will really help. It can never hurt to rewrite the formula. So this is how we write it, at least how I've written it. So h of z is a product of 2 functions. Z squared minus 3z plus 1 times z cubed minus e to the z. That is a product of 2 functions. Let's label them. This one as f and this one as g. So f, I've already listed it. I could rewrite it if I wanted to. It doesn't hurt to do so, but I'm just going to find f prime. I'm going to call this baby f prime. Because sometimes, like in the next example, sometimes your function is already called f. So you want to not get it confused. Now, as you get better at this, by the way, as you do this more and more frequently, you can skip doing this step. You can skip doing this and do it in your head a lot of the times as you practice this more and more. But f prime, by the power rule, that would be 2z minus 3. And g prime, 3z squared minus e to the z. By the power rules, that's a bunch of power rules, and then that's the derivative of e, which is itself. Any questions on those derivatives?
Minus 1 for the power rule. G, the EZ, oh, we're not doing the derivative of it yet.
No. Well, no. The derivative of z cubed with 3z squared and the derivative of e to the z is itself. Yeah, it takes practice. That's why I told you guys I wanted you guys to practice 2.2's material a little bit before today, but that's okay. It's all right. We can still practice it. There's still plenty of time, but this thing will build on itself a lot. This is where we start snowballing. So if you like, please take some time to practice all this stuff today, if you can. Today, tomorrow, the next day, every day is math day. But anyway, so f prime is 2z, g prime is 3z squared minus e to z. So h prime of z is f prime, so f prime g plus g prime f. That's what we're thinking in our heads. We're talking about a product. So it's f prime g plus g prime f every time. So f prime 2z minus 3 times g, c cubed minus e to the z, plus g prime 3z squared minus e to the z times f, which is z squared minus 3z plus 1. And I wrote that don't like that. There we go. And then we simplify, right? No, we don't simplify. I don't care. That's unnecessary work. And that brings you to an early carpal tunnel syndrome way faster. Do not simplify unless you need to use it. If you need to use the, like, maybe if this question was asking, find where h prime has a horizontal tangent line, then I'd simplify. But as it stands, I'm not going to. Next one. This is a quotient. It's a function on top and a function on bottom. So I'll label this as my f, my baby f, and my baby g. Baby f and baby g. So baby f prime is 2x. Baby g prime is also 2x. If you're not using color to color code it, write your baby f with a smaller f. Like maybe this should be, honestly, it should be like this. It's really tiny, baby f. So, quotient rule. F prime g minus g prime f all over g squared. Every time, see if you get it right. If you get it wrong, rewrite it properly, and then try again on another problem. It's a great way to memorize it. So, the real f, its derivative would be f baby f prime, so 2x times g, x squared minus 1, minus g prime, which is 2x, times f, which is x squared plus 1, all divided by g squared. So x squared minus 1 quantity squared. And yeah, you could simplify it without too much worry, but I don't care. That is unnecessary filler work and busy work. You've taken the derivative here. I'm good with it. Any questions? Okay. Another one. I'd like you to do these two, this problem A by yourself. I will slowly fill in details. Yeah, it's got fractions. What of it? It's okay if you don't remember the derivatives of these functions. You will practice it enough that you will memorize it. I typically don't provide formula sheets in calculus unless it's a really, really obscure thing. So we'll talk about related rates a little bit later in this unit, which will require you to know several area and volume and perimeter formulas. I will always provide those. You do not need to have the volume of a cube memorized or the volume of a cone. That's unnecessary. I've got the answer up here if you'd like to check the work. Should get the derivative of the, so that's a product of two things. So baby f prime would be 3/4 x to the negative 1/4 by the power rule. And g prime, the derivative of natural log is 1 over x. So that's why g prime is 9 over x plus the derivative of x would just be 1. So f prime g plus g prime f. So 3/4 x to the negative 1/4 times 9x, 9 ln x plus 9 over x plus 1 times x to the 3/4 minus 5 would be the derivative. Now we move on to B. Unless there's any questions on that. All right. So g of t is equal to t cubed e to the t over t plus 1. That's a quotient, right? It's a function over a function. Easy enough, right? This is baby f, this is baby g, we're all good. So I'm going to rewrite f as t cubed e to the t over here. Oh, wait a minute. That's a product. So the derivative of baby f requires a product rule. So this is a product rule inside of a quotient rule. So we got to do more. So we need and since the formula is f prime g, and we've already used baby f, we have to use baby f and baby g. So this is baby f, little baby g. and baby g. So baby f prime is equal to 3t squared, and baby g prime is equal to e to the t. You have to call them baby f. And then if you had to do a third one, you call it baby f and baby g. So you just make it smaller and smaller and smaller until it's invisible. Anyways. Oh, yes.
I was gonna say, how do you know that those are like smaller primes, I guess, than like just having like prime F prime?
So I just really write them small. I like to color code.
I meant like,
Oh.
versus like a normal problem where it only has like one set of primes.
Uh-huh.
How do you know that this one has, I guess, two sets of primes? Like,
Because this one had a product inside of the quotient. So whenever you see, like, you're gonna look at each problem separately, like every single problem is unique. And so when you look at this one, you say, okay, I need to take the derivative of f. Wait a minute, that's a product. So I need to do a new rule inside it. So baby f prime, not baby f prime, but baby f prime is 3t squared e to the t plus g prime f, so e to the t cubed, which I'd prefer to have it written as t cubed e to the t, but it's fine either way. And then baby g prime, luckily for us, not baby g, but baby g prime. G prime is just 1. So start your function on the very left-hand side of the page, like right over here. So g prime of t. Sometimes these things take a long time to write. So g prime of t, the actual function, g, is f prime. So 3t squared e to the t plus t cubed e to the t, just because I like the fact that the e is at the end, but it's not required. That's f prime times g, t plus 1, minus g prime, which is 1, times f, which is t cubed e to the t, all divided by g squared, so t plus 1 quantity squared. I guess this one didn't require as much room as I thought. Boom. So sometimes you need to do multiple problems. Sadly, this next joke is becoming less and less relevant, but hopefully it still hits the mark. Wait, no, not this one, the next one. So, all right, so this one here, k of t is a product with a quotient in it. The first term, that t squared minus 3t plus 2 over t squared minus 1, that is a quotient. So let's label this baby f and label this baby g. And so f is t cubed plus 3t plus 2 divided by t squared minus 1. So baby f is the top, baby g is the bottom. Now, if you start feeling comfortable with this, this is where I'd like you to get to. This is how I'd like you to see it. I'd like you to write down f and then say, okay, well then baby f prime is f prime, so that's 3t squared plus 3 times t squared minus 1 minus 2t times t cubed plus 3t plus 2, all divided by t squared minus 1 squared. That's where I'd like you to get, where you can just do it in sequence. Because the more you write down, the more chances there are that you make a minor mistake. And I don't want you guys to make minor mistakes because minor mistakes pile up, especially in calculus. But I know that's hard to read, so I'm going to zoom in for it for a second. So that's baby f prime. 3t squared plus 3 times t squared minus 1 minus 2t times t cubed plus 3t plus 2, all divided by t squared minus 1 squared. However, when you're starting out, it doesn't hurt to just write down what baby f and baby g, baby f and baby g are on the sides. Baby f prime is 3t squared plus 3, and baby g prime is 2t. Hence f prime g minus g prime f all over g squared. And be doing that a lot. Doing the chain rule, we're gonna be doing the product rule, quotient rule, and the chain rule a lot. Be your bread and butter. So, any questions on baby, like the red F prime's derivative? Then baby G. G is, so when I look at this, and this kills me every time I see it happen, because it's not wrong to do it this way, but you might be looking and saying, oh, well, I got to do a quotient rule. No, you don't. No, you don't. So note, we could use the quotient rule. Here, but easier to view it as 3t to the negative 2. So it's a common classic mistake that I see students make is they try and do the quotient rule on 3 over t squared or 5 over t or 3 over x plus 1, and it's really unnecessary. It's really putting way too much work. You're bringing a gun to a knife fight. You're using the wrong, like you're using too much machinery. You don't need to use the quotient rule here. Is that okay? Does everyone see? Yes.
So anytime probably you have a variable term in the denominator with an exponent by itself, and you've not been added to the denominator, you should apply that negative exponent rule. you're
Yes.
saying? Okay.
Oh, like anytime, like you can, like anytime I see like a number, like if that was e to the t over t squared, then then you'd have to use the quotient rule because there's no way to really
Reduce those variables.
like the reason why I'm so the reason why I say that with a number is because with a number, the derivative of a number is just 0. So it doesn't really make sense to take the derivative of it. It's just unnecessary work. But if that said e to the t over t squared, then we'd have to use the quotient rule. Or you could use the product rule if you did a little bit of, if you did convert it, but either way. So g of t, baby g is 3t to the negative 2 minus t to the 8/5. So g prime is negative 6t to the negative 3 minus 8/5 t to the 3/5. Remember, you can always use your calculator to do that fraction for you. But the key thing is you're gonna be subtracting 1, which can be rewritten as number over number. So if your denominator is 5, you can think of it as 8/5 minus 5/5, which is why it's 3/5. So we have f prime, we have f, we have g prime, we have g, we have everything we need to do the product rule. Because remember, at the very beginning of this problem, it is a product rule. So start this at the very left. Start this one definitely. So k prime of t, f prime, which is over there. Let me zoom out a little bit so I can see it. Is bracket 3t squared plus 3 times t squared minus 1 minus 2t times t cubed plus 3t plus 2, all divided by t squared minus 1 squared times g, which is 3t to the negative 2 minus t to the 8/5 plus g prime, which is parentheses negative 6t to the negative 3 minus 8/5 t to the 3/5 times f, t cubed plus 3t plus 2, all divided by t squared minus 1. Beautiful. What a beautiful function, right? Now, if you want to be cheeky, and you're strapped for time on an exam, you can really, like, I'm okay with it. I don't love it, but I've had students write k prime of t equals f prime g plus g prime f, and then just go, like, you could do that. I'm not going to stop you, especially if it's a long one. But if it's not a long one, please just write it out. But I'll probably just write on your exam cheeky, and then just give you full credit because you are doing everything. You just don't want to rewrite it. You're embracing your true math major potential and being lazy. Every mathematician is lazy. So anyways, but since this is our notes, we want it to look perfect. All right. Now this one here, every situation is different. Every function that you encounter will most likely require some new idea. So for this one, that's a product rule with a product rule inside it. It's a double product rule. It's almost starting to look like a triple product rule. Does anyone know what I'm talking about when I make that joke? Does anyone remember double rainbow? Was that before your time? I think that's before your guys' time. Double rainbow was a thing on the internet way back in its infancy. It was a great joke. But anyways, it's less and less relevant. Maybe, and even the inception, because this is a productception. That still is that's missing the mark, I think. I got to get rid of it. I don't want to get rid of it. It was a hilarious joke. But anyways, this right here, just to save on time, that's 1 plus x to the 1/2. I know I'm going to need to take a derivative of it, so I'm going to convert it to exponential form right off the bat. Now, this one, you could either view it as this is your f, and this is your g, or you could view it the other way. You could view it as this being your f, and this being your g. Or if you really want to go freaky, you could do this as your f, and this is your g. If you really want to, you could do any of those things. It doesn't matter which you choose, as long as you're being consistent. I guarantee you, if you do it a different way than I do, your answer will look different. But if you really, if you want to do this when you're trying to fall asleep, simplify it on both versions, and you'll get the exact same answer. So I'm going to do it by making this one my f and this one my g, because I didn't want to deal with a larger function, because the second two functions are both binomials or two-term functions. So it's a little less convoluted, but it doesn't matter. It really doesn't. So f prime 6x plus 5 by the power rule, g prime. Once you start getting good at it, hashtag get good, like in law, or Dota, or if you play HOTS, Heroes of the Storm, maybe that's your thing. Still relevant. You can do this all at once. You can do this as you go along. So g prime, 1/2 x to the negative 1/2 times x to the negative 3 plus 7 plus negative 3x to the negative 4 times 1 plus x to the 1/2. Take a second to see if you can see that. If you can, you're ready. You're ready to skip that extra step. I'm still going to write down the important information here in just a second, but that's where I'd like you to get. I'd like you to get to that point where you're comfortable doing a product rule in your head with simpler stuff, quote unquote, simpler functions. Trying to do this with like a product rule with a product rule with a product rule, everything like that. No, take your time. But as you get better at it, you can skip those steps. But I'm going to still do this the long way for you as well. So g is equal to 1 plus x to the 1/2, x to the negative 3 plus 7. So this is my baby f. This is my baby g. So baby f prime is 1/2 x to the negative 1/2. Baby g prime is negative 3x to the negative 4. And that's where I got it. And if you want to do some simplifications, you want to write this as minus 3x to the negative 4 instead of plus parentheses negative 3x to the negative 4, be my guest. Feel free to do as much algebra as you want. You don't have to, like, you can simplify. Please don't on this problem. That would be a real nightmare for me to check to make sure you got the right answer. But if you do it, I will figure it out. So dy dx, now that we have everything, dy dx is f prime, which is 6x plus 5, times g, which is 1 plus x to the 1/2 times x to the negative 3 plus 7. That's f prime g plus g prime bracket 1/2 x to the negative 1/2 times x to the negative 3 plus 7 minus 3x to the negative 4 times 1 plus x to the 1/2. That's g prime times f, which is 3x squared plus 5x minus 2. Whew, what a doozy. Yes, Jake.
When do we know to put brackets?
So the brackets are not, so technically you could use parentheses. So since this is a like this multiple terms, that definitely needs to have parentheses. This does not need to have brackets. The first set, I'm only doing it to symbolize that that is G. I'm saying that's F times G. Like this is F prime. This is G. It is, sorry, F prime. It is not necessary to put the brackets on it. I just wanted it for your notes for you to see that that is the product rule in action. That is F prime times G plus G prime times F. It's never a bad idea though to put the parentheses. Parentheses can, I can think of very few situations where adding extra parentheses would cause problems. Okay. Practice early, practice often. Very important. This stuff is not for the faint of heart. And if like, because when we start talking about the chain rule next week, it's going to require using product rules and using quotient rules. So if you don't practice this, chain rule will be hard. So please practice it. Please, 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 please. This weekend, get together with your friends, bust out a couple cold ones, some Mountain Dew, Code Red, or Baja Blast, or whatever you got, whatever you kids drink. And bust it out with them. Have some fun. I promise it's going to be a great time. And as an observation now, there were a couple exercises in the Unit 2.2 notes, and there's a couple problems in the exercises that we couldn't do before without simplification. Now we can do it without simplification. Your answer will not look the same, but you could check. All right. Next thing. Very, very fun problem. So ddx of f of x with a bar and then x equals a, or dy dx bar and then at the very bottom x equals a. This means the derivative evaluated at x equals a, i.e. f prime of a or y prime of a, or sorry, let's say dy dx of a. It's the derivative, like that's just another notation for evaluating the derivative at a specific point.
So the vertical line is evaluated?
Yes. So that is a symbol that we as mathematicians have adopted to mean evaluate at x equals blank. In later math courses, it might mean that that's where a sequence starts or something like that. And it all depends on the context because mathematicians have never found a good way to a consistent language for everybody to work with. There's when you get into vector calculus and things like that, there's Einstein notation, and then there's another one with all this weird stuff. We just never worked with it. Okay. So that notation is needed because we're going to talk about this problem. You're given the following information. You're given the graph of f, and then you're given information about g. We don't know anything about g other than the fact that, and the way you read this chart, by the way, this is saying that when x is equal to -3, g of x, so g of 3 is 5, g prime of -3 is -2, g of 1 is 2, g prime of 1 is 6. Is that okay? So it's saying find ddx of f over g evaluated x equals 1. Phil, I don't have f. I don't have g. I don't know what those equations are. I can't do this. Yes, you can. Believe in yourself. Fact is, if you're not given functions, it means you need to apply purely the definitions. So by definition, this is equal to f prime of 1 times g of 1 minus g prime of 1 times f of 1 divided by g of 1 quantity squared. The derivative of f divided by g is the quotient rule, f prime g minus g prime f all over g squared. And we're evaluating it at x equals 1. Take a second. It's okay. Okay, we are a little behind. That's okay. That's okay. We'll be fine. We'll be good. We'll be great. And so now comes the harder part, in my opinion, is interpreting this. So g of 1, not bad. Because g of 1 is right here. G of 1 is 2. G prime of 1, also not bad. This is equal to 6 from the chart. And we already found this. So this g of 1, that's equal to 2. But what is f prime of 1 and what is f of 1?
F of 1 we get from the graph.
F of 1 we would get from the graph. So I'm going to highlight that one in red. So there is 1. So f of 1 should be -3. What's f prime of what's f prime of 1? Louis says 0. Does anybody else agree? Yes, because this is equal to 0. It's because if you drew a tangent line at x equals 1 has a slope of 0, which implies that f prime of 1 is equal to 0. The derivative, when you evaluate it at specific values, represents the slope of that tangent line. So since we have a horizontal tangent line at x equals 1 on our curve, that means that the derivative there, so f prime of 1 is equal to 0. So this is equal to -18 divided by 4, which is 9/2. I guess I should technically write 0 minus -18. That's 0 times 2 is 0, minus 6 times -3, which is -18, divided by 4, which is 9/2. All right, and that is as much as we can go over today. So once again, you have your exams. The review is due next Wednesday. I have office hours on Tuesdays and Thursdays, but if those times do not work for you, send me an email with some times that work in your schedule and we can try and do something. We can try and set something up. And you can always email me. But otherwise, you guys have a great rest of your day, a great weekend, and I'll see you guys on Monday.
Quiz on Monday?
No quiz on Monday, quiz on Wednesday. I think pretty much all of our quizzes are on Wednesday except for like one of them. So, but I look at the course calendar to double check. Okay. All right, guys. See you then.